E aí, pessoal, tudo bem? Tudo bem com vocês? Sejam muito bem-vindos para mais um webinar do DevOps Bootcamp by Establis, nossa quarta edição, né, Amanda?
Isso aí, quarta edição, bem-vindos a todos. É muito bom estar aqui com vocês de novo e fico muito feliz de ter muita gente aí nova com a gente. Quem é a primeira vez, depois dá um oi aí para a gente saber de onde que vem, de que estado, se é de BH. Depois dá um toque só para a gente saber se a gente está aí, da onde, né, que está vindo, de que estado.
Qual lugar do Brasil, né?
De qual lugar do Brasil que está vindo.
Exato, e tem um pessoal aqui que já chegou um pouquinho mais cedo, ó. Juninho Tecnologia, Edson Moraes, Wesley Carcheno, Ives Jacques, Augusto César, grande Fernando Pimenta, mais uma vez aí, nosso parceiro, nosso amigo de longa data, Marlon Coutinho, Vinícius César, Josué, Henrique Ferreira Silva, Juliane Ferreira, Fábio Coutinho, Edson Mendes, Fabrício, Grace, Vinícius César, Carlos Eduardo, Bruno Bahia, Josué, Silas Thiago Medeiros. Ó, tem a galera do Brasil toda aí, viu, Amanda? São Paulo,
coisa
Anápolis,
boa.
Natal, Governador Valadares, ó, perto da minha cidade, de Tchotchó, 140 quilômetros de Tchotchó. Curitiba, São José dos Campos. Isso aí, galera. Vamos chegando aí que essa palestra hoje promete demais, esse evento de hoje promete demais. Só alguns recadinhos básicos aqui, né, Amanda? Isso. Quem quiser se juntar lá no nosso Telegram, né, @DevOps Bootcamp, então tá aí na tela para vocês entrarem no nosso canal do Telegram. Quem quiser mandar algum e-mail com dúvida, né, perguntando a respeito dos treinamentos que a gente faz, né, temos aí de Docker, Kubernetes, está para sair um de Terraform ano que vem, um de monitoramento também.
GitLab.
Isso, GitLab também. Pode mandar para contato@devopsbootcamp.net. Né? Queremos também agradecer os nossos apoiadores aí, né? Tem o Vida de Programador, onde você pode entrar lá no Vida de Programador e ter 10% de desconto em todo o site com esse cupom, né? Boot Vida de Programador. E também a gente quer pedir para vocês publicarem no LinkedIn um print da live de hoje com a hashtag, né, DevOps Bootcamp, se inscrever no canal e participar dos sorteios, que todo evento que a gente faz, né, Amanda, a gente procura ter uns prêmios legais. E hoje o que a gente tem de prêmio aí para a galera?
Tem muito prêmio legal. Como sempre, quem participou, né, do mês passado, acho que deve ter visto aí nas redes. Então, assim, todo mês a gente busca parceiros, né, para contribuir, para fazer com que o evento se torne maior e traga para vocês muito mais conhecimento e também diversão e prêmios legais. Então, hoje a gente tem o Vida de Programador, que vai nos prestigiar com o livrinho de tirinhas do André Noel, que é muito bacana. A gente tem o Nerd Stickers, que vai também liberar para a gente um cupom de desconto de R$150 para vocês curtirem lá na loja e pegar os stickers mais legais que tem. E por último, a gente vai sortear um Kindle. Então, fiquem ligados, todo mundo vai participar do sorteio. E quem participar...
Todo mundo foi inscrito, né?
Que foi inscrito, vai participar desse sorteio. E o Kindle, né, gente, para quem trabalha com tecnologia, é o que há na leitura, facilita bastante. E depois a gente vai, no finalzinho, a gente vai fazer esses sorteios, né, para não atrapalhar a dinâmica aqui do evento. A gente vai começar para quem é a primeira vez, né, que está participando, que nunca participou, a gente vai apresentar, né, o palestrante. Hoje é um palestrante muito importante, assim, para a gente que já trabalha com DevOps, com Cloud Native, está nessa jornada, porque é um cara que já tem muita experiência e que vai trazer muita experiência legal do que ele já tem de mercado e de vida, e depois a gente abre para as perguntas e respostas que a gente vai liberar, tá bom? Para vocês. Então, deixa eu ver aqui, o senhor André, você está famoso aqui, ó, a Daniela Falopa está aqui também hoje, beleza. Seu Fernando já começou a chorar as pitangas pedindo o Kindle, né?
Ele vai ganhar do jeito que ele é sortudo, né?
Então, outro recadinho que eu queria dar, quem quiser ser parceiro, empresas que quiserem ser parceira da nossa jornada aí de transformação dessa comunidade maravilhosa, é só entrar em contato com a gente, tanto eu quanto o André, a gente está à disposição para conversar e bater um papo e trazer mais parceiros aí para o nosso DevOps Bootcamp, ok?
Isso. O pessoal aí do Brasil inteiro, né, Amanda? Lavras, Lauro de Freitas, Itapecerica da Serra, Vitória, a Dani também aí. Dani Valau, como é que você tá? Tudo bem? BH também em peso, São José dos Campos, então muito legal. Catalão, Goiás, né? O Anderson falando aqui que prêmios estão ainda melhores nessa edição. A ideia é essa, né, galera? Cada edição a gente ir melhorando com o apoio de vocês. Quanto mais gente se inscrever no canal, quanto mais gente divulgar, né, publicar as hashtags lá no LinkedIn, tornar o DevOps Bootcamp conhecido, mais a gente vai poder, né, atingir mais pessoas e chegar aí no Brasil, no mundo inteiro, tá bom? Então, sem mais delongas, a gente deixa outros recadinhos para os finais. Eu vou passar a palavra aqui para o Christian Posta, para o Cris Posta. Quem não conhece ele, né, ele vai se apresentar um pouco. Ele trabalha na Solo.io, já trabalhou muito tempo na Red Hat também. Ele é um dos caras que mais manja de Istio, né, de Service Mesh. Então, quem mexe com Kubernetes, microserviços, Cloud Native, tem que saber o que é Service Mesh, tem que saber o que é Istio, o que é Envoy, e ele vai falar um pouquinho sobre esse assunto com a gente hoje, tá bom? A palestra vai ser em inglês, tá bom? Não vai ser traduzida nem nada disso. Porém, no final, se vocês quiserem fazer alguma pergunta, pode fazer em português aqui, quem não domina o inglês, que a gente traduz para o Christian aqui, ok? Então, vamos lá?
Só lembra, André, que podem ficar, para todo mundo que foi inscrito, vocês vão receber os materiais do Christian, tá? O vídeo, a gente vai disponibilizar os vídeos depois. Então, material, vídeo, vocês recebem também, tá? A gente libera isso aí tudo para o e-mail de vocês e também no nosso canal. Então, podem fazer as perguntas, depois que ele se apresentar a proposta, a palestra dele, a gente abre para as perguntas, ok?
Então vamos lá. Okay, Christian, so please introduce yourself. It's again, it's a real pleasure to have you here with us, okay? And the stage is yours. Oh, and after your presentation, if some people want to do some questions for you, even in Portuguese, I will translate for you, okay? So
that sounds wonderful. Amanda and Andre, thank you, and the rest of DevOps Bootcamp, thank you so much for having me, and a big thank you also to the folks who are watching and who are attending. And I'm very happy to be here and very happy to speak with a Brazilian audience, one of the first times, hopefully not the last. So let's get started. We're going to talk today about microservices and how, DevOps on the periphery, right? DevOps is a very big part of how you operate and successfully run a microservices style architecture. And we're going to specifically be talking about some of the tools that you might need to successfully do this. All right, so my name is Christian Posta. I'm a Field CTO here at a startup called Solo.io. And the topic of today's presentation is exactly the space that Solo.io and what we're focused on, solving problems in this space. I've been involved in open source communities for quite a long time. Most recently in the Istio and Service Mesh community, which is going to be some of the focus of this talk. But my background is, I come from a developer background. I've worked with large organizations, large banks here in the United States, and others around the world through my time here at Solo, or before that at Red Hat, and before that at another startup involved in open source and distributed integration, and even before that, right? So, but I'm very passionate about helping people. The space that we're in, and the part that I'm passionate and excited about is connecting applications, and is not a very new space, right? We've had previous iterations of technology to help solve some of this same problem, but the problem landscape and context has changed enough that a new generation of technology needs to come in and fill in some of these gaps. And like I said, I'm passionate. We have a lot of experience here at Solo and helping folks adopt microservices, build the right architecture, organize the processes and workflows around it for your specific organization. And I like sharing some of the stuff that I've learned or experienced either through writing on my blog or speaking at conferences or writing books and so on. So I am writing a service mesh book for Manning right now. So I'm definitely very excited to be here and talk with you all. So Solo, we're a startup growing fast, fairly successful. We just closed our Series B round of funding 3 months ago. And what we're focused on at Solo is building that infrastructure to allow your applications to communicate with each other across clouds, across clusters, on premises, in public cloud, wherever. But we're focusing on the parts where the applications, they need to talk with each other, and they're doing so in a cloud environment, most likely, right? So things like containers and Kubernetes and so on. The assumptions and the foundations on which you build a microservices style architecture, that infrastructure has changed. Pods and containers and applications, they could be scaling up, they could be scaling down, they can be becoming unhealthy. They need to be load balanced across multiple different availability zones. Traffic needs to come into these systems, the traffic needs to be secure, and so on, right? Now, you look at containers and Kubernetes and some of the platforms and the CI/CD that you're building around those Kubernetes and containers. But once you've deployed your applications, these things need to talk with each other. And the next part of CI/CD and the automation around getting these things to talk with each other, that is what we're focused on at Solo. We have 2 main products. One is Glue Mesh, which is loosely what I'll talk about some of the pieces that make that up or the problems that we're solving with that. And the other one is Glue Edge, which is Edge Gateway built on Envoy proxy, specifically to help folks start to modernize, start to bring microservices into their environment and eventually get to Kubernetes and containers and solve some of the edge problems like rate limiting and OIDC and open policy agent type authorization and that kind of stuff. So the 2 of them complement each other. The mesh and the gateway complement each other very well. And we have a developer portal and other extensions on top of it. So that's all I'll say. Solo, we're a very exciting company. We're solving very, very widespread and difficult challenges. But what we'll talk about today is once you start to go down this path of adopting microservices, right? And you're doing that because you want to enable your organization to deploy code faster. Typically, these are bigger organizations, right? And there's a lot of process and a lot of contention in the org, or the application architecture is monolithic. So if you change one thing, you have to change everything. So going to microservices, building up your automation, being able to build the engine inside of your org to deliver features and deliver code faster. Now, the practicality of this, once you actually start doing this, right, now you start to figure out what are the right boundaries for the microservices, what are the right APIs, how you do build and automated deployment, automated testing, and so forth. The practicalities of doing this make you, you come to the realization that this has to be done in a way so that it still is compliant, right? There's a lot of large organizations that we work with in financial services or healthcare or insurance. There's governance and compliance that has to be satisfied. You want to build these systems so that they're highly available, right? Just because you split things into different services, you could have one service go down, and if you've architected it incorrectly, let's say, if one service goes down and takes everything else down, that is not a very good architecture. So you need to have fault domains and failure domains architected in such a way that you're able to maintain high availability. You need to be able to scale out your services, and you might have these network constraints around. Some of the networks are private, some of them are public, some are in between. And when you deploy your services, you need to think about the security, the observability, and how these things connect. So some of the patterns that you see for getting services to communicate across this wider deployment, and we'll look at this through the lens of maybe a couple different clusters, but this cluster could be Kubernetes clusters. These could be just a group of VMs. These could be running on-prem or in public cloud. In this case, we're just looking at the different patterns for how a service from one cluster could talk to the service in another one. And the first pattern is the simplest, which is these clusters are all just on the same network, right? And there's direct connectivity from, in this case, the account service and the product service or the history service, right? So in that model, at least the basic connectivity is provided by the network. Now, a different model is maybe you have two different networks. If you're talking about Kubernetes clusters and they're on, they're not routable between the two of them. And so to get the connectivity from one of these clusters to the other, you have to somehow expose the services so that they are routable. One way to do this is a load balancer, or on Kubernetes, something like a node port, or some kind of gateway. And that's what allows you to bring these services together to be able to talk with each other. Another approach is just a single load balancer for all of the services that run in a different network or a different cluster, right? And so in this case, the account service needs to talk with the history service, and this goes through a common shared load balancer, and the load balancer knows how to route to the specific services in the backend. So these are some of the high-level patterns that if you deploy into multi-clusters and multiple zones and so forth, that to get A to talk to B, there are some of these different topologies that we do want to be aware of. Now, let's go up a level, right? We talked just very vaguely about the different, how would an application in one network talk to the application in another network? Load balancers help, right? Now, let's go a level up. Let's go to the application, what the applications are sending on the network wire, right? So the traffic is going from one service to the other, but what is that traffic? What's happening with that traffic? So here's where an important piece of technology has emerged on the cloud native scene in the ecosystem. Just like Kubernetes was such a powerful piece of technology for managing a bunch of nodes and deploying and orchestrating applications onto them, Envoy proxy is slowly becoming the de facto magic behind solving some of the problems, networking problems between applications. And I'll go into more detail. But so Envoy is a proxy first and foremost. So you may already be familiar with proxy technology like Nginx or HAProxy or some of these. Envoy is a proxy very similar to those types of technology. Now, what's special about Envoy is that it was built 100% from the ground up to live in this highly dynamic world and be driven by an API and dynamically adjust its behavior based on how the API is configuring it. So this means you can do traffic shifting, you can change security properties, you can do dynamic load balancing and locality-aware load balancing. Even if services are coming and going and failing and so on, Envoy does not need to be restarted for any of this. It just will dynamically evolve based on the configuration settings that you supply to it. So Envoy, in this context, implements a handful of very powerful features. Things like priority and locality-aware load balancing. Things like circuit breaking and outlier detection. So that if services misbehave, first of all, you can load balance around them and fail over to the right regions if a particular region is misbehaving, but also stop sending traffic to a particular service if it's misbehaving for a period of time. They can also implement things like timeouts and retries and backoff strategies and budgets and traffic routing and shifting. So maybe you have all your traffic going to your service, but you introduce a new version of your service. You can use Envoy to route a fraction of the traffic, a percentage of the traffic to the new version and start to do things like canary rollouts and that sort of thing. Traffic shadowing, which means take a copy of the traffic and send it to the new version. And then if the new version misbehaves or whatever, it doesn't impact the live traffic. Is able to do authentication and authorizations. And just as important as any of these other features, Envoy collects a very large number of different telemetry and metrics and access logging and so forth. And you can use Prometheus to scrape these and pull them into a time series database or whatever, and then do actual analysis. As traffic is flowing over this proxy, do a lot of real-time analysis and understanding about how the applications are behaving. So Envoy is a proxy, like I mentioned, right? And this proxy is also efficient and powerful enough to be deployed with the application itself, which is a slight twist on the typical deployment of a proxy, which is usually as a middle proxy or a reverse proxy, right? Traffic comes in to a single point, and then the proxy does its stuff. Envoy can do that, but it can also play the role of an application-centric forwarding proxy. And so what that means is the application, when it talks to the rest of the network, it can talk directly through Envoy without taking extra hops. Right, so it'll talk to Envoy, and then Envoy will send the traffic where it needs to go upstream to the rest of the network. Right, so in a practical deployment, what this might look like in Kubernetes is you deploy a pod with two containers. One that has the application and one that has the Envoy proxy. And if you're familiar with Kubernetes, a pod is atomically deployed, right? They're deployed together, and their life cycle is together, these two containers. If you think about it through the lens of a virtual machine, then what we're talking about is the application is deployed on the virtual machine, and an Envoy proxy is also deployed on that virtual machine. And when the application talks to a different machine or a different service living somewhere else, it will talk first to localhost, to Envoy, and then Envoy will talk to the upstream network. And so with this pattern, that's called the sidecar pattern, we can do amazing things for the application. We can do load balancing decisions with the application. We can do security and rate limiting and so on with the application. So if we look at Envoy in some of these same networking models and look at Envoy as part of the application, because that's what it does. It's solving some of these networking challenges that the application would otherwise have to solve by itself, right? You may have seen in previous iterations of cloud native or microservices style frameworks, things like Netflix OSS or Twitter Finagle, or things like Light4j. These application programming frameworks would solve a lot of these problems and do it inside the application. The problem is this would get entangled with the rest of the application logic. If you wrote your applications in different languages like Python or Node.js, you would have to go find different libraries and frameworks for those languages. If there was a bug in one particular library, you would have to fix it there and possibly the other ones. And then you get stuck maintaining 4 or 5 or more different language-specific frameworks for solving the exact same problem. And so that's why Envoy here is so powerful, because we're solving a large set of these problems in one way. And all we're doing is we're deploying that with each of the applications. So Envoy is a very critical piece to this puzzle. Now, you may have heard the term service mesh. And service mesh is a pattern that deploys Envoy similar to what we saw here, but is able to make sense and control and configure all of these different Envoy proxies that might exist in your network, with your applications. So you may have heard of a handful of a lot of the large popular ones are based on Envoy proxy. So if you learn and understand Envoy, then you basically understand the foundational pieces to any of these service meshes that are built on Envoy. So in the service mesh world, we're talking about specifically this pattern, the sidecar pattern. The proxy lives with the application instance and is responsible for these networking things: circuit breaking, timeouts, retries, distributed tracing, load balancing, service discovery, telemetry collection. All of these things that an application otherwise has to do is now implemented out of process from the application and consistently, regardless of what language or framework that you use to build the application. Right? And so in the service mesh adds a control plane layer. And this control plane is how operators of the platform owners, users, service owners, that they want to control the configuration and the routing and the security policies and so forth. They interact with the control plane and use that API at the control plane. And then the control plane translates that into the configuration that needs to go to each of the proxies that live in the service mesh. So ultimately, you end up with a architecture that looks like this. You have a lot of different services, and they're communicating and talking with each other as part of your CI/CD pipelines, deployment pipelines, and so on. You're making changes to these different services, but you need to control the network and the routing and collect telemetry and observability about what's happening between these services so that you can roll back or roll forward and do canary releases and so on. So the mesh provides this communication backbone or backplane that enables a lot of this automation. And if you didn't have this and you're building a microservices architecture, then you can very quickly get into a scenario where making changes to your applications, making changes to your microservices ends up being like a black box, and you have a lot of unintended consequences. Things start to fail for unknown reasons at times, and you lose confidence in being able to make changes to your system, especially as it grows bigger and bigger. And that's the opposite of what we're trying to do with a microservices style architecture. So to recap on what service mesh solves the challenge of service to service communication, and it brings load balancing, secure service to service communication. So if we come back here, when the traffic goes from an account service to the user service, the Envoy proxies, as you can see, are in the request path on the origination side and the termination side. As the traffic passes through, Envoy can decide to encrypt the traffic, right? So that the communication between account and user is fully secure, encrypted using mutual TLS even. And the applications themselves wouldn't have to know or worry about this. Like if you're a developer, and I come from a developer background, come from a Java background specifically. I remember in my days writing Java code and service-oriented architecture services, dealing with the key stores and trust stores and certificates and cipher algorithms and all of this, trying to get all that stuff to work was such a pain. Right now, you can see in this model that encryption and security is there, but it's provided now by an application networking component like Envoy. All right, so we can do secured communication. We can control the traffic since all of these little proxies are in the data path. We can control the traffic, and it gives the service mesh ultimately gives you a programmatic API for managing the communication and policies between the services in your microservices architecture. Very similarly to how Kubernetes gave you a programmatic access to deploying and managing large sets of services across lots of different servers. Or even similarly, how the public cloud gives you API access to on-demand infrastructure. So this technology, this cloud-native technology is following the same pattern. It gives you an API, but in this case, specifically to control the policies around your applications. Now, I put this picture up here a little bit tongue-in-cheek, just because I know that this is the CNCF survey from 2020, specifically around service mesh. I know that the survey was done it's not a very reliable survey. A lot of ambiguity in the way they presented the questions. But even so, you can see that there is a dominant open source service mesh implementation, and that is Istio. Istio is an open source project with open governance and is backed by people like Google, VMware, IBM, Red Hat. You see others from Salesforce and us at Solo part of this community contributing to it, using it, and so it's a very big community and has been widely deployed. So the question for this graph was what service mesh are you deploying in production? So these are the players, at least. I would argue the pie would look a little different, but even just based on the survey that they did, you can see that there is a dominant leader here. Now, just like adopting containers and just like adopting Kubernetes, there are challenges to bringing in the infrastructure to support a microservices style architecture. The end goal, as I started off with at the beginning, was build an IT engine to be able to deliver software faster. So the end goal is good. Now, how you get there are both technological challenges, but also ecosystem and organizational challenges. So I don't know how many of you are running containers and Kubernetes and so on. Bringing all of the developers, security, networking, platform, infrastructure, DNS, all of these people together to work on to bring up a single platform. There's a lot of challenges in that. And we see similar challenges in adopting a service mesh, some of which are listed right here. But so let's go back to you're deploying your microservices, you're deploying them in such a way that they need to be secure. They're running on these cloud platforms like Kubernetes, maybe on-prem, maybe on OpenShift, maybe on EKS or AKS or GKE in the public cloud. And the services they need to communicate with each other. They need to solve these challenges. They need to be compliant. They have to pass audit. They need to be highly available. They need to be you might have some public or private networks in there. So let's go back to what the service communication would look like in an environment similar to this when you have a service mesh in place. The first pattern that we saw when we first started talking was the flat network pattern, where everything can just talk to everything. Everything's on the same network. when a call goes from the account service to the history service in a different cluster or different group of nodes somewhere, we're using the sidecar proxy. We're using Envoy to solve things like timeouts and retries and circuit breaking and distributed tracing and mutual TLS, all this stuff. That's all good. But the network routing is fairly simple. It just goes from the account service to one of the replicas of the history service. That's fine. But if you have if you have a network like this, it's a little bit simpler. Not everybody has a network like this, but there's still some challenges here. Because if you run the service mesh in this model that we see here, you notice that the control plane has to run somewhere. And the control plane in this model is typically running with one of the clusters. If that cluster goes down, now you've lost control of the rest of the application networking. And so that's not very good. So let's take a look at a different model. So, well, slightly different model, I guess. In this diagram, we see there are separate networks, but still only one service mesh control plane. So because these are separate networks, they have to communicate through some sort of gateway or load balancer. And so Envoy can play the role here as well at the edge. And so traffic comes in, let's say cluster 1, account service talking to one of the services in cluster 2, will always go through this gateway. The gateway will then pass through or route the traffic to the right backend service. So this is fairly typical. Again, the challenge with this is there's only one control plane in this case. And if cluster 1 goes down, then you lose control of the application networking. Another model is to actually run different control planes, run different networks. Your clusters are running in different networks, and the networking between the account service and the history service running in cluster 2 follows the gateway model, but the different control planes are separate, right? So if one cluster goes down, you don't suffer the problem of losing the control over your application networking. You now have two totally independent clusters. And so this ends up being, when you start to go down the path of a service mesh and adopting a service mesh, the first step is obviously get it working and operational in your organization. But in terms of architecture and deploying this in such a way that it does not become a single point of failure, is to architect with tenancy and multi-cluster in mind, specifically around the failure domains that are either implicit or explicit in your architecture. And what I mean by that is, what is a section of the architecture that if it fails, it will fail on its own, independently, and not take down other parts, right? So identifying what are the boundaries for these fault planes or domains is incredibly important when you're building microservice architecture in general, but specifically in the infrastructure that's supporting it. And in this case, we're scoping the failure domain to a single cluster. So if a single cluster maybe you misconfigure the cluster and it goes down, well, then everything kind of goes down together, but it doesn't impact everything else. Maybe on that cluster, you misconfigure Istio, and that destroys everything on that cluster. That's fine, but it doesn't impact everything else, right? So this is a very important piece to this puzzle. So let's go. If we take a look at an example of the account service talking to the user service through the service mesh, like I said, all that traffic first goes through the proxy. And the proxy can be smart enough to know that there's a user service locally, but there's also a user service remotely. The application doesn't have to know anything about this. And in this model, when everything's good, traffic's flowing, account service to the user service, ideally in the local cluster, that's all good. But if things start to go wrong, then we need to fail over to cluster 2. And we don't really want to involve the application. We shouldn't have to make code changes because of this. We'll use the service mesh and the fact that the Envoy proxy is in the data path and can control the routing and transparently control the routing. Now, some of the challenges of operating a multi-cluster deployment of a service mesh like Istio are around setting up things like the security boundary. So are the services in cluster 1 able to talk to the services in cluster 2, right? So let's start with that. Are they able to? The second part is, should they be allowed to? Who's managing across the different deployments and different clusters of your microservices? Which services are allowed to and have permission to talk with the other ones? Especially if those other clusters are running in a different region or a different cloud. Maybe you have some on-prem and some in a cloud and so forth. So creating a consistent security boundary, building consistent configuration model for authorizations and authorization policy, determining what services are allowed to talk with which others. Service discovery between the clusters and between the deployments. The fact that cluster 1 knows that there's a user service on cluster 1 and cluster 2, how does it know? Something has to tell it. Something has to know. So there has to be some service discovery and orchestration for this type of problem. Another thing is defining failover rules between the services. Maybe we want to fail to the next closest cluster. Maybe we want to fail to a specific different cluster for compliance reasons. Being able to be very fine-grained and control of the configuration across these different clusters. That's kind of a difficult problem to solve, and so on. So, operating this type of infrastructure, once you start to get to multiple clusters, is non-trivial, I would say. And so that's why at Solo specifically, these are problems that we're working on solving. At Solo, we are the experts in Envoy proxy, experts in service mesh. We support Istio in production, so we do offer enterprise support for Istio in production. But then when people get there and start deploying it, once they get to multiple clusters, multiple networks, these types of things, then we need some way to manage that overhead and that burden. And so we built an open source project called Glue Mesh. So Glue is sort of the brand that we've had for about 3 years now, which we came up with specifically because what we're doing is we're combining these different services. Some might run on VMs, some might run in containers, some in Kubernetes, some on-prem and somewhere else. But at the network, we're gluing together the routing, the observability, the security, and so forth, from the edge down into the applications themselves. Service mesh is part of this. Envoy proxy is another part for edge gateway type functionality. But Glue Mesh specifically is intending to glue multiple clusters, multiple different meshes together, and manage them and operate them in a simplified way from a single pane of glass. So this is important because the way we've solved network to application connectivity problems in the past, we always said, here, put something in the middle. Put API management gateway in the middle. Put it in the middle. Oh, before that, what did we have? Enterprise service bus. Put it in the middle. Everything talks here. Everything goes through here, right? Before that, enterprise application integration, the hub and spoke. Put all these message brokers in the middle and put everything through there, right? In this model, we're specifically saying decentralize how we implement and enforce the traffic policies, right? All of the images you saw earlier were the enforcement points, the proxies, are living with the application or across clusters, right? We're optimizing for the cloud environments where things are constantly changing, some failing, some scaling, and so on, but in a highly decentralized manner. Now, from an implementation standpoint, that is highly desirable. No implementation bottlenecks. But at a large organization, there needs to be some balance with that, right? We can't have everything be fully decentralized. What we want is the policy and the configuration to be centralized. We want a single pane of glass to operate all of this. The implementation of the enforcement and how we apply the policy, all that stuff, that doesn't have to be and shouldn't be centralized, right? So that we have, with Service Mesh, and especially now with Glue Mesh, we have this nice balance between decentralized, distributed systems, friendly implementation, and centralized from an organizational friendly standpoint. And so Glue Mesh allows us to solve the service discovery problem, solve the access control problem between services across clusters, to solve the API problem, because there's an API problem. When you deploy all your microservices and deploy all your stuff into a mesh or a Kubernetes or whatever, you still need some way to expose those services to end users and developers and so on. So you need a developer portal. You need these types of capabilities. So let me. So here's just sort of an example of what a multi-cluster Istio or service mesh deployment might look like, where you have to manage all these different configs, shuffle them across all of the clusters, and hope and pray and cross your fingers that things are done consistently and securely. Glue Mesh offers this idea of a management plane. So you have these Istios running, and you use the management plane to simplify those operations and deploy the configuration consistently. So let me show you a quick demo. We have two different clusters here. You can see we have cluster 1 and cluster 2. Both of them are running Istio, and they're different Istios. So if I come over here, let's go Istio system. See, we have an Istio control plane running here, and we have an Istio control plane running here. These are separate, different clusters, different Istios. Let's go back. The workloads that we're running here is the Istio book info demo, but we have some variant of the deployment here with reviews V1 and V2. Over here, we have reviews V1, V2, and V3. All right. So now what we want to do is we see that their service mesh is deployed here. We have the application proxy and the Envoy proxy deployed with each of the pods here. So the service mesh is deployed. What we want to do now is operate and control the traffic, the service discovery, the identity, the traffic encryption, all this. We want to make this consistent and easy to manage across these different clusters. So what we're going to do here is we're going to do a quick demo here. So let's look at Glue Mesh, the UI. So we have the UI here. What we're going to do is we're going to register both of those clusters with the management plane. All right, so if we come back to our diagram, we're going to interact with the management plane here. We're going to register cluster 1 and cluster 2, tell the management plane about those clusters. So if we come here, we see that it is working. We registered cluster 1. Now let's register cluster 2. And once we register with the management plane will be smart enough to go discover the different service meshes that are running in each of the clusters, as well as the different services and workloads that are running in each of the meshes. All right, so we registered them there. Let's come back, take a look at our UI. We see two different clusters here. If we click on anyone, we see that the service mesh has been discovered. If I click on the service mesh, we can see the different workloads, the different services, and any of the policies that we may have. We don't have any policies yet just because we haven't done that part yet. So that's good, right? So now we're able to discover, and we can manage the meshes individually, but we don't want to manage them individually. What we would like to do is treat the two of these meshes, or more of them, maybe there's 10. We want to treat them as a single logical application network. I pointed out in the slides that operating multiple different control planes across multiple clusters with different sets of services on each, that can be kind of challenging. So to simplify that, with Glue Mesh, we can simplify the model. Instead of thinking about these 2 clusters, 2 meshes, or 10, or more, 80 of them, we can just think about logically 1. And in Glue Mesh, we have something called the virtual mesh. In this virtual mesh, we can list the service meshes that we want to have part of this logical abstracted mesh, and then go apply it. All right, so we're going to apply this to our management plane, and then the management plane from here can then treat these different clusters as a single unified mesh. And we'll take a second. The management plane is working to make that happen. And that is looking good. If we come over here now to our dashboard, click on overview, we see we don't have 2 anymore. We have 1. We have 1 logical mesh that is made up of 2 different service meshes from 2 different clusters, right? And then treated as a whole, we see 11 different services, 14 different workloads, because some services can have more than 1 replica of the workload. And we see our no policies have been written yet, and no WebAssembly filters have been deployed yet. Now, I'll get to this part in a second if I have time, but we're also able to extend the capability of the mesh by writing WebAssembly filters or plugins that can be injected into each of the proxies. So we already have a lot of control over the traffic in the network around routing and security and so forth. But we can now inject our own custom behavior into those proxies by using WebAssembly, which we'll try to get to. Let's see. Do we have our service, everything come up and running? Almost. Let's check sometimes the demo script does things out of order. Make sure all these things look okay. No, they don't. So let's restart them. We're restarting the workload so that they pick up the new certificates that have been issued as part of this virtual mesh. And so what this means is all of the workloads now, their certificates, they come from the same root certificate, so that traffic going from one cluster to the other will be trusted. All right, so let's take a look at what that might look like. So using this federated mesh, now when we write configuration, we don't write configuration for cluster 1 or cluster 2 or cluster 20 or cluster 37, right? We write the configuration for the logical abstract mesh. And then the logical abstract mesh goes and puts the translates it and puts the configuration on the correct clusters, depending on where they should go. So if I go here and we take a look at 90 page, we can see our demo application running here. If I refresh it a couple of times, we bounce back and forth between the black stars and no stars, and that's fine. But what we want to do is, let's say we deployed oh no, what did I do? on default. Let's say we deployed version 3 of the review service on cluster 2. Maybe that's our canary cluster or staging cluster, and we want to route some traffic to cluster 2 when we call the review service. In this particular case, reviews v1 has no stars, reviews v2 has black stars, reviews v3 has red stars. And we can see everything is going back and forth there because we're only routing to traffic in cluster 1 right now. But let's say we want to specify a traffic policy that anytime you talk to the review service in cluster 1, route 75% of that traffic to cluster 2. Right? So let's apply that. And now if we give that a second to take hold, if I come over here and refresh this, we should see red stars 75% of the time. All right, so now traffic is going from cluster 1 to cluster 2 only through the configuration that we made using Glue Mesh. So you can see here the policy that we wrote here is traffic shifting policy. And under the covers, so if I click on debug here, and we look at one of the specific meshes, we can see under the covers, the Istio resources were created by Glue Mesh and were properly configured depending on what cluster so if you see that right here, the virtual services are slightly different between the two clusters because of the direction of the routing that we specified here. There's a lot more stuff. There's a lot more interesting functionality that we can do. One of the things I mentioned was we can, so I'll just go here real quick. I don't have time to do the full demo, but if we look at the meshes, we saw a virtual mesh made up of 2 Istios, but it doesn't have to be just Istio. Even though at Solo, we support Istio. We support Istio in production, and that comes with the Glue Mesh enterprise side of things. But the open source part, it doesn't have to be just Istio. In this case, you can see Open Service Mesh. So we can manage Open Service Mesh from this management plane as well, including if you went to something like AWS and you were using App Mesh, which is their own service mesh, we can bring that into the management plane as well. And then I mentioned the WebAssembly part, where if you want to make changes to a particular behavior or functionality in the network, we can use WebAssembly to inject custom behavior and use Glue Mesh management plane to orchestrate that and manage that as well. So I believe I'm out of time. Let's come back here real quick. Show the demo. Go check out Glue Mesh open source. Check out Istio. Check out Envoy proxy. Check out some of the other things that we're doing here at Solo. Again, many thanks for attending my session here. Happy to take questions both here through the moderators, as well as reach out to me individually. I know sometimes I do these things, and I know this was not really a 101 level, let's say, introduction to service mesh, but I'm happy to do that. I'm happy to fill in the blanks or come do a workshop for you all or whatever it is. So again, thank you for attending. Don't hesitate to reach out and then go check out some of these open source projects that we're working on that are in the community itself.
Thanks, Christian. Thanks a lot for your presentation. We already have some questions here. I'm going to put the first one on the screen. It's in Portuguese, but I will translate for you, right?
Sure.
So Leonardo Gonçalves asks, Istio 1.8, it comes with interesting support to integrate VMs, virtual machines, to the service mesh. Mm-hmm. How does you, Christian, see the kind of approach being utilized for serverless, like AWS Lambda?
Right. So if I understand the question, so Istio is the functionality around bringing virtual machines into the mesh is maturing, right? Ever since Istio 1.5 and 1.6, 1.7, now 1.8 is out. 1.9, if everything stays on track, which should be in February, 1.9 should have the first real community support for VMs. And what I mean by that is, up until now, all of the functionality has been in what Istio calls alpha or experimental mode. But by 1.9, it will be promoted to beta, which still might not sound very, very strong. But in beta, that's when the community will then start supporting the APIs, start supporting the functionality a little bit more, and we'll probably get a lot more usage. Now, the question is, now Istio supporting bringing VMs to the mesh? What's the story with serverless functions or something like Amazon Lambda? Now, what I can tell you is, so for example, this is a question that we get from some of our customers. And for that, what we recommend is, so we have Glue Mesh that I talked about here, which is the service mesh related stuff, right? But connecting different networks, connecting different parts of the organization typically needs to go through some kind of gateway anyway, right? Now, if you come here and you go and look at Glue Edge, which is our gateway, which also plugs in very nicely with Istio, I do want to show that Glue Edge is based on Envoy and can directly call Amazon Lambda. So you can combine the gateway with the mesh and have this ability to bring Lambda into the picture as well. So I think that's a good first step. I think what we'll end up seeing is that each cloud provider which they will all have their own service mesh, right? AWS has App Mesh. Azure, they have Open Service Mesh, which is open source project, but they're building their own Azure Mesh. Google, same thing. What we think will happen is each provider will include their mesh with the functions, the service that they provide. But even so, if you want to stay cloud agnostic, or you want to stay try to increase your leverage against vendor lock-in and that kind of stuff, using something like Glue Mesh to abstract the service meshes, as well as something like Glue Edge to integrate with Lambda, I think was a good approach.
Okay, awesome. Another one from Fernando. It says, a cluster itself is already a high availability solution. In which scenarios do we need a multi-cluster? And when do not think in multi-cluster?
So this is my observation, and this is to answer your question. When Kubernetes, for example, first came out, the idea was, well, why don't we just run these big clusters and run everything in it? Run dev, IST, UAT, production, run everything in a single cluster. Because there's tenancy, kind of. There's, that we could stand up the master control plane, and that can be highly available and so on. And then what we found through practice is that's not the case. Especially coming from Red Hat, where I've worked with some of the early adopters of something like OpenShift. OpenShift, of all of the Kubernetes clusters, probably has the best multi-tenancy capabilities. And we saw initial early adopters just do that. Maybe not dev and ISC UAT, but production, massive 1,000 node clusters in OpenShift. But then what we found is that sounds nice on paper, but in practice, those clusters do get unhealthy. Those clusters can and do take down production. And so just like with any other part of your infrastructure, you want to have redundancy. You want to have high availability, and you want to scope those failure domains as tight as possible. Now, I'm not saying one application should have one cluster, but you will have natural fault lines in your organization, maybe by product, maybe. So what we've seen people go, like some of our customers have got 80 clusters, and 3 of the clusters per product or per organizational unit, or some are on premises, some are in the public cloud. But how you split that up might be more determined by these these forces, your availability needs, compliance, isolation, away from other people, noisy neighbor, all the scale, data locality, these are the things that would drive your need for multi-cluster. But I think believing that a single cluster in production is highly available enough, maybe for some use cases that might be, but for some of the large organizations that we work with, or for those whom, high availability and scale and all this stuff matters, then, figuring out the right balance between multi-cluster and single cluster is what we end up doing.
Yes, it's kind of a high availability for a high availability, right? So
right.
You can get enough of that. So another one. Let me see. Okay, another one from Leonardo. A glue mesh takes care of distributing the certificates in each cluster.
Yeah. So when I showed the demo, what was happening, I don't know if I have the slides. Let me see if I can go back to an older slide deck somewhere. Let me see. So you might be able to show you. Maybe next time I'll include it in the deck. But I know some of these older slides that I have. Maybe this one. Right here. It's not. It's a little bit outdated, but I think the point can still be made. Each one of these Istio clusters, each one of these control planes, has its own certificate that it uses to sign the Leaf workload certificates, right? And then if these workload certificates have a certificate, or if these workloads have a certificate, then that can be used to establish TLS and mutual TLS with the other workloads. Now, Istio control plane signs the certificates using a intermediate signing certificate. And what we did, by default, if you just install Istio, it's going to set up its own certificates, right? And they will be completely independent. What we did with Service Mesh or with Glue Mesh is we established a shared root, and in the demo we just created our own shared root. But you can also bring that in from an existing organizational shared root or shared intermediate. And then we told Istio, hey, go create new certificates, use these as intermediates, and then send a certificate signing request to Glue Mesh, so that the root then has signed all of the intermediates in the chain, and then now any of the workload certificates that come from this intermediate will also come from the root, regardless of what cluster we're talking about. So Glue Mesh unified that identity domain by basically sharing the root between these different clusters.
All right, okay. Let me see. So I have one question for you. Also, I'm not an Istio specialist or kind of that, but why does Istio change its architecture? Like now it's like a single monolith, and in the previous versions were not. So why is that?
That is a wonderful question. Let me see if I can find the link here. If you go to my blog, so this is something I wrote about a year ago. Let me see if it's still. I think we have here, right? So I even titled it Istio as an example of when not to do microservices, right? And so I can send this. I don't know if there's a chat or I can put it on the private chat here, or you can post it. But in this blog post, I go through all of the motivations that were. So it starts off with assumptions, right? Because Istio started off with assumptions. Istio assumed that when you deploy Istio, and then do I have any diagrams here? Yeah. When you deploy Istio, that different parts of the control plane would be operated by different teams. The team that is interested in doing the config might be a little bit separate than the team that is interested in doing the security and certificate rotation, which might be different from the observability team, and so forth, right? So the assumption was, if we build this thing in such a way that it can be operated independently across independent teams, then we would have the right velocity of change and independence, and we achieve the microservices goal, which is organizational independence, so that you can move faster. What ended up happening in practice is, when you deployed Istio, it was really just a single team that was managing all of this. And a single team managing all of these moving pieces and complexity and that can be a nightmare, right? If you just have a single team and everybody's on the same page, then you don't need all these different pieces. It just makes it more complex. Mm-hmm. And so, both from a sort of an organizational standpoint, actual adoption based on real data, we saw that the microservice approach was serving no benefit. In fact, it was slowing things down, because these different components needed to talk with each other. They needed, when you did upgrades, you had to be very careful in what order that you upgraded them, and so on. So the benefits, it basically came down to the benefits that microservices bring to the table were not being served here in Istio. And so the idea was to then, well, what is the best operational surface for Istio? And collapsing those down into a simpler set of components was the right approach for Istio.
Yeah, it's a surprising assumption for me, because to imagine that different teams will operate different parts of the same product, so to speak, it's a kind of a different approach of assumption for me. But
so keep in mind, Istio was built. It was a first built, and the assumptions were built that somebody like Google is going to operate it, right? And in Google, they do have different teams that operate different parts of Google Cloud, right? And so that was some of the early assumptions. That has obviously changed, because that's not the case. But I think that was some of the reasoning behind going down that path.
Yeah, that's nice. And not everyone can be Google, right?
And not everybody needs to be. Yeah.
Yep, exactly. So, but in my opinion, turning Istio in this single monolith, especially because it's written in Go, it is actually more easier to maintain and to write the code there and so on. So awesome. Okay. We don't have any more questions here for you, Christian.
Sure.
If you want to to say goodbye or to do some final announcements, so feel free to do it.
Sure, I appreciate it, Amanda, Andre, and everybody who is listening. The rest of the folks who put together DevOps Bootcamp and the sponsors and all that, very much thank you. Thank you for bringing me here and allowing me to speak. Please do reach out if you have questions. Easy questions all the way to difficult questions. I'm happy to take any of them. And again, thank you so much.
Awesome, and thanks you, Christian, for accepting the invite to talk to a Brazilian audience today. Okay.
My pleasure. Yep. Thank you.
Thanks, Christian.
Okay. Bye, Christian.
Bye.
Bye, Christian. Gente, espero que vocês tenham gostado. Agora a gente vai começar a festa, né? Mas aqui, a gente teve... A gente, tanto eu quanto o André, quanto o time, né, do DevOps Bootcamp by Stabilis, a gente ficou muito feliz em ter essa participação do Christian, porque para a gente é um presente gigante, porque a gente vê que o Brasil ele já está se tornando, né, um polo aí de profissionais. O Christian ele vê essa importância, ele tem, né, ele vê que a gente tem, que o Brasil ele tem uma importância tanto na tecnologia quanto nos profissionais que a gente tem formado. Então, isso é mais um estímulo para vocês, para que vocês continuem com a gente, continuem evoluindo na carreira, continuem buscando conhecimento. Então, assim, o nosso propósito é buscar ainda mais pessoas com a experiência dele, com o tanto de bagagem que ele tem, com a vivência que ele tem, para que vocês aprendam muito mais. Então, o que a gente quer deixar aqui para vocês, que como quem eu acho que tem muita gente novata aí, não conhece, né, como que é a metodologia do evento. Todo mês a gente faz um DevOps Bootcamp, né, live. Então, cada mês a gente vai trazer um conceito diferente, a gente vai falar de uma ferramenta diferente com um palestrante diferente. Então, a gente não vai falar antes qual que é a surpresa, até para não deixar, né, todo mundo sabendo, que é o que a gente gosta de fazer, são eventos diferentes para que vocês estejam aqui com a gente. Eu espero que vocês tenham gostado. Vocês vão receber o material, vão receber o vídeo, então não se preocupem caso vocês não tenham perdido alguma coisa, pode ter certeza que vocês vão poder ver aí quantas vezes forem necessário, ok? Vamos lá para os recadinhos. André, deixa aí o canal do Telegram para o pessoal se cadastrar lá, porque lá no Telegram, só para que vocês fiquem sabendo, lá é o espaço que todo mundo coloca lá as dúvidas, tiram as
vagas.
Coloca as oportunidades, a gente tem muitos parceiros, então, vagas, oportunidades de negócios, artigos, tudo que vocês imaginarem, a gente conversa lá. Então, para quem não está ainda participando do nosso canal, entre lá, faça parte e ajude a colaborar também, porque DevOps é isso, né? É colaboração, é compartilhamento de ideias, e a gente quer isso, a gente quer que vocês cresçam junto com a gente. Sobre os webinars, eu já deixei para vocês, claro, janeiro a gente volta com mais novidades e com muita coisa boa aí que vem para o ano de 2021, se Deus quiser. Os boots, como vocês sabem, também a gente tem, a gente é especialista, né, em mão na massa, nas ferramentas de DevOps e Cloud Native. Então, as melhores ferramentas vocês podem aprender com mão na massa. Então, está aqui o André, que faz o de Kubernetes, a gente fez o último em novembro, a gente sempre lança turmas, tanto para a comunidade quanto para empresas. Então, quer aprender com método prático, procure a gente. Se tiver alguma dúvida, como que é esses treinamentos, é só chamar a gente, pode ser pelo Telegram, pode ser pelo nosso e-mail, contato@devopsbootcamp.net, e a gente vai passar isso para vocês. Então, tem de Docker, a gente está lançando também o de Terraform, GitLab, a Establis, que é nosso parceiro, é parceiro oficial da GitLab, então vem muita coisa legal que vocês também podem começar a viver isso aí com a gente em 2021. Sobre as oportunidades, eu acabei de falar, todos os parceiros que a gente tem são empresas, né, que estão vivendo esse momento com a gente. Então, quem é parceiro do DevOps Bootcamp podem postar as vagas, as oportunidades que tem nas empresas, e a gente preza muito por quem vive essa transformação. A gente gosta de empresas que têm o mesmo propósito que o DevOps Bootcamp tem, que é transformar pessoas. Então, a gente tem um objetivo muito claro, transformar vocês. Então, fiquem ligados no canal que vocês vão estar recebendo essas oportunidades. Curtir a página, a gente ficaria muito feliz com vocês, por vocês curtirem as nossas páginas, nossas redes sociais, tanto o canal do YouTube, quanto mais gente curtir a gente, mais patrocínio, mais parceiros, mais brindes, mais conhecimento a gente vai conseguir trazer para vocês. Chame os amigos, chame os tios, chame os cachorros, que isso vai ajudar demais a gente, né? Vamos lá agora para o sorteio. Como que é a dinâmica aí? Quem participou nos anteriores sabe como que é. Hoje a gente tem alguns sorteios legais. O primeiro sorteio é da tirinha, do livro de tirinha do André Noel, nosso grande parceiro aí. Eles são sensacionais. Quem não conhece, curta lá a vida de programador. Eles têm uma lojinha que são o store, né, deles. Tem tudo que vocês imaginarem. Então, como que nós vamos fazer esse sorteio? Exatamente como a gente fez no mês passado. Eu tenho certeza que vocês printaram tela aí do que o Christian falou, pôs aí sinalzinho de mais, florzinha, tudo que vocês imaginaram aí durante o evento, durante o que ele falou. Então, o que nós vamos fazer? Bora lá no LinkedIn, posta lá com a hashtag DevOps Bootcamp, a melhor tela, o melhor depoimento, eu não quero nem tela, pode ser o melhor depoimento do que vocês viram hoje, vai ganhar o primeiro brinde. Então, para quem tem dúvida se isso vai acontecer, é só perguntar nos depoimentos anteriores. O Thiago Martinian ganhou, né, mês passado. Então, a gente faz, a gente promete e a gente cumpre.
Será que vale ele ganhar esse mês de novo, hein?
É mesmo, você ganhou, né, Thiago? Então, ele está aqui com a gente hoje de novo, ó, para você ver. Então, vai lá no LinkedIn, posta lá um depoimento do que vocês acharam, pode falar do que vocês acham que a gente pode trazer nos próximos meses, não tem problema, a gente quer uma coisa legal.
Sugestão de temas, né?
Isso, que faça com que a gente traga temas legais, ou que vocês acham que a gente pode agregar para vocês, o que a gente está trazendo de novo. A gente está aqui para fazer DevOps acontecer. Então, bora fazer uma coisa bacana, o que for mais legal, a gente faz, a gente entrega esse livrinho e chega na casa de vocês. O cupom, agora para o próximo, a gente tem também para sortear o cupom valendo R$150 da Nerd Stickers. Todo mundo conhece, é uma das maiores empresas aí de stickers, né? Os stickers deles são sensacionais.
Adesivos.
Então, adesivos. Vocês vão adorar, e vocês podem escolher o que vocês quiserem, né? São R$150 em compras na loja. Então, é a mesma coisa. Posta lá um depoimento top e vai ganhar também o melhor depoimento. E agora, eu tenho 3 sorteios que a gente vai fazer com depoimento também, porque aqui todo mundo merece ganhar, que são os sorteios do DevOps Professional, que é o curso que a gente está sorteando hoje. Os melhores depoimentos, por que eu mereço ganhar esse curso do DevOps Bootcamp by Stabilis, vai ganhar o curso. Esse curso, ele te prepara para a certificação. Ele é um curso que faz com que você conheça todo a metodologia de DevOps, né, a cultura, e te prepara para você conhecer o pipeline, né, para quem está começando o DevOps. Ele é bem legal, ele é bem no Academy que a gente tem, ele te mostra o passo a passo. Quem já até curtiu fez a primeira edição, ganhou ele, né? A gente fez uma promoção, né, na primeira edição, né, André? 2.000 pessoas ganharam esse curso, ele é bem completo. Então, quem postar o depoimento que por que merece ganhar esse curso, tá lá no LinkedIn, coloca a hashtag ganha, ok? Agora vamos para o principal. Você quer fazer ou eu faço, André?
Pode fazer aí.
Esse último brinde, ele é da Stabilis, é um Kindle, e vai ser...
Mas você tem que sortear o Nerd Stickers primeiro, não?
Não, o Nerd Stickers?
É R$150. E
então,
todo mundo vai ter 15% de desconto, mas aí agora você vai sortear um voucher de R$150 pro Nerd Stickers, para uma pessoa.
Não, mas eu acabei de falar, ué. O Nerd Stickers é a pessoa que postar lá o melhor post do Nerd Stickers no LinkedIn.
Ah, tá, saquei. Entendi.
Aí, o que eu vou sortear agora, que é para todo mundo, né, que se inscreveu,
E que está aqui online agora.
Que está aqui online. A gente vai, como é que fala? Vai ganhar o prêmio especial, que é o Kindle, que é patrocínio da Establis. Quem tem dúvida a respeito da Establis, corre lá no site da Establis, é a nossa parceira. A Establis está com a gente desde o início, ela faz transformação digital para as empresas, então é um parceiro top e está oferecendo o Kindle, está em todos os nossos eventos. Então,
eu quero ganhar esse aí, hein?
Não, mas assim, os palestrantes, tá, gente? Organizadores não ganham. Então, vamos lá ver quem que vai ganhar, tá? Espera aí que eu já vou fazer aqui o sorteio. Já estou colocando os números aqui. 222. Espera aí, deixa eu ver aqui na planilhinha, que a doutora Grace, do meu time, top, me mandou. Espera aí. Vamos lá. 222. Se não estiver, a gente manda um e-mail com tudo bonitinho, tá? Tomara que seja uma menina, né, gente? A gente os últimos foi tudo homem. Nossa Senhora, vamos chamar as mulheres para participar, porque o negócio está ficando feio. Não, tem homem demais. E olha que a gente tem. Olha, é homem. Vamos lá? Kleber Rodrigues, Cisdata, analista de infraestrutura. Ele está aqui hoje? Kleber Rodrigues?
Kleber nos Rodrigues. Comentários, não.
Não? Kleber Rodrigues, nada?
Não.
E aí, como fazemos, senhor André? Você que manda.
Eu não, você.
Eu. O Thiago tá com gracinhas aqui, ó. William Peixoto. A mulher aqui, ó, Juliane Ferreira. Ó, pra você ver, Juliane, isso mesmo, Juliane, tá vendo? Ela tá aqui com a gente, ó. Juliane, só porque você acendeu a mãozinha aí, ó, você vai ganhar um DevOps Professional, porque eu quero mais mulheres, viu? Aqui, ó, a Ana, tá? Juliane Ferreira, se você não tem o meu LinkedIn, me procura lá, Amanda Pinto, que eu vou precisar dos seus dados para te enviar o curso, ok? Então, me procure que eu te passo todos os dados, tá bom? Vamos lá, né? A Maiara aqui também, ó. Só ganha quem está aqui, né? Então, vamos lá fazer o sorteio. Peraí. Vou fazer vou tentar mais uma vez, tá, gente? Então, Kleber não está aqui, beleza? Vamos fazer aqui. Peraí. Sim, vou fazer de novo aqui, só para não... Um minuto, que já está sorteando aqui. Peraí, meninos. 327, 327. Vamos lá, voltando aqui para a telinha. Aldo Costa Silveira, tá aí? Aldo Costa Silveira. Se não tiver, aí porque eu coloquei só pelos comentários. Aldo Costa Silveira, está? Gente, pelo amor de Deus. Aldo Costa Silveira. Aldo Costa Silveira. Estou aqui. Aqui, ó, ele está aqui, ó. Estou aqui. Aê! Aqui, ó, meninas. Então, aqui, ó, para incentivar as mulheres, ok? Laila, vamos lá aqui, senhor André, para a gente terminar aqui e fechar. Senhorita Laila, a Ana, que é nossa parceira aí, dona Ana, Laila, deixa eu ver aqui, estava a... Deixa eu ver aqui, peraí. Ana, Juliane, que eu falei. Gente, eu vi Maíra, né? A Ana já tem meu LinkedIn, claro. A Maíra eu acho que tem. Juliane, me procurem que eu vou passar para vocês o curso do DevOps Professional. O que vocês vão me
Pode mandar no e-mail aí, né, Amanda, que está na tela?
Ou então me manda no e-mail.
É mais fácil, né? Eles mandaram um e-mail e falar assim, ó, eu sou a fulana e estava lá no dia da live.
Isso, porque eu tenho que fazer com que vocês tenham acesso ao curso. O que vocês vão me prometer é que vocês vão indicar a gente para mais 10 meninas. A gente precisa de mulheres em DevOps, ok? E, gente, agora a gente tem, né, que finalizar, mas eu queria agradecer muito a presença de todas vocês, os homens também, os meninos, que são muito importantes, né? E já deixar marcado o nosso encontro em janeiro, ele sempre acontece numa quinta-feira, às 17 horas, então já não marca nada, geralmente é no final, né, entre o dia 17, dia 20, já fiquem aí mais ou menos com a agenda já marcadinha por esse tempo, vai vir coisa muito boa em janeiro, a gente só não pode, né, adiantar, e eu gostaria muito de agradecer por esse ano, talvez a gente, né, não tenha a gente não se fala em eventos mais, mas assim, agradecer por vocês estarem com a gente todo esse ano junto e desejar um ano muito legal para todos vocês. E que ano que vem seja um ano muito melhor, com saúde a todos, e que vocês estejam com a gente novamente, acreditando aí nesse propósito de transformar e levar o conhecimento de uma forma diferente para todo mundo, ok? E aí, doutor André?
Pessoal, obrigado aí mais uma vez pela presença. Foi muito bom ver o engajamento da galera aí. E é isso, né? O que a Amanda falou, assina embaixo. Nos encontramos no ano que vem, né? Em janeiro de 2021. Esperando que 2021 seja melhor do que esse ano louco e estranho que a gente está vivendo, né? Ainda, mas faz parte da vida, né? Mas vamos lá. Obrigado aí, galera. Tamo junto aí.
Muito obrigada. Beijos.
Valeu, pessoal.